All right, before we go on, I'm going to go ahead and clear and CLC just to give myself a nice tidy workspace to work with. I've still got the same script from my last video, but I'm going to start a new section here, and I will call it More Types of Input. Because so far we've done input as numerical values, and we've done input that is a string or text, but the user can also put in a matrix, which is kind of neat. So let's do the same thing we did before, but change the time input to a matrix. Allow the user to enter multiple times all at once. This is a fine way to do it. So I'll say, let's do gravity again, input, what is the value acceleration due to gravity? I'll put a space, close the quote mark, and then suppress the output after the parentheses. So that will be a variable called gravity. That's kind of allowing the user to choose whether they want the distances to be in meters or feet, by the way. And then times. So instead of asking start time and increment, we'll just say, tell me all the times you want. Input, enter times in brackets with semicolon to separate rows. So what we're doing here is we're going to ask the user for a whole matrix. They get to enter it, and I'm going to add a space here and a semicolon at the end to suppress the output. And I've given the user some instructions because they may not know they need square brackets with semicolons to separate the rows. And then what am I going to do with all these? Once I get it, we'll calculate the distance traveled. We'll do that by saying 1/2 gravity times the times squared. And remember that dot exponent is because we might have a matrix. It's a good habit to get into. It doesn't hurt if we end up with only a single scalar, but it's a must if we have a matrix. Suppress the output and let's create a table. This time let's make a table using a slightly different format. I'll build a table by creating a matrix out of first the times, and I'm going to turn it into one long column using this colon that we've seen before, and then distance traveled, and again same thing, and I'll say display as vectors using operator. Cool. And for some reason I have this note here too. This might be important. Write this down somewhere. If you get in the middle of a program that gets stuck, you can hit Control and C. So hold down Control and hit the C key to break out of execution during a program. That might be needed. Okay, let's go ahead and run this section and see what we get. Oh, my table. No, I actually want to see that one. So I'm going to leave this one with the with no semicolon because that's my display. This is my way of displaying to the user what I'm doing. So acceleration due to gravity, we'll say 9.8. That's meters per second squared. And now it's giving me the chance to, let's move this up a little bit, to enter the times. So I might say 0, 1, 2, 3. I might have another row here, 4, 5, 6, 7. Whatever we end up with. Square brackets and a semicolon to separate the rows. So I hit enter and notice it has turned this into one long thing, but it did it by column. So 0 and 4 were the first column, and then 1 and 5 probably should have sorted it better, but that's how we can use a matrix as an input if we want to, if we think carefully about what we really want to do with it. All right, so we've got a little bit more practice with inputs. Next up, we're going to talk about how to display this. So far, we've been displaying by drawing a picture. We used table earlier, and then we created a kind of a table, not a real table, but using this, just making a matrix out of all of our functions. So we'll look at other ways to display output to the user next time.